Thank you. So the agenda for today, I'm just going to reiterate, is looking at the teaching practices that are rooted in research and that are evidence-based. But also think of today as kind of a sort of a modeling, my kind of think aloud process of how I planned a unit and put it together. And then looking at the curricular expectations connected to the resource. And then we're going to walk through the resource and kind of explain how it would be implemented. So I'm going to ask for this particular session, if you have a pen and paper handy, to jot down any questions that you may have. Because of time constraints, I want to make sure there's a lot to get through today, that I get through it. So what I'm going to do is hold off for question and answers at the end of the session. So feel free to ask any questions. I'll stay as long as needed, so that to help you sort of understand or answer anything that you may have. All right. So what the resource that you will receive at the end of the session is you will get the mini sample unit plan that has all the links, which includes student graphic organizers, and as well as the slides to the sessions. If you are listening to this recording, you will receive the same things. I'm probably going to repeat this because I know people are going to be joining in, but all resources will be translated into French. And you guys, can you hear me? Okay, because I'm getting a message that you guys can't hear me. Okay, thank you. All right, and all of these resources will be posted on ARPDC site. Okay, so I'm going to talk about the resource you're going to receive briefly, the document. The resource that has been developed is under Creative Commons licensing. And really what that means is you're free to copy and redistribute the material in any format. You can remix, transform, or build on this. So modify and adapt, of course, we want you to do that. And so what it also means is when you're sharing it, you give appropriate credits. So the credits are, the logos are on the bottom, that it belongs to Alberta Regional Professional Consortium, and that it's not sold on any other medium like Teachers Pay Teachers. And share alike means you can still modify and adapt and remix it, but that you would share you would, again, under the same licensing. Okay, so what you're going to receive is a document, and the unit is called From Bouncing Balls to Bandages, Using Purpose to Choose Materials. So in the document, there is a unit overview, as well as curricular connections, which we'll unpack today. There are the list of materials required. There are links here to the student handouts that were created for each investigation. And there's a teacher version that you can see, sort of examples. And then the materials that are required, or supplemental materials that are optional if you can't find some of them that you can use. The student graphic organizer is the investigation laid out. So you'll get something that looks like this, which we'll walk through. And then the teacher reference kind of is the example of it, of what you may hear. So of course, examples are going to vary because these need to come from your students. And then the lesson layout format basically is your learning goal with the procedures, kind of informally here. And then thinking about inclusion of all learners. How will all learners access the learning engagements? I have linked Universal Design for Learning principles, which are connected to that. I primarily focus on vocabulary, so I will pull out and highlight vocabulary for that particular lesson and provide sentence stems that you may use. The odd time I might put in some instructional strategies that you may consider or use. Then the next column is the assessment for learning column. And what you get is you will get a link to the actual formative assessment checklist. You may or may not use it. You get a forced copy. That means it becomes yours and you can modify and adapt it. So what you're doing is the assessment, the cusps or skills and procedures that are connected to that particular lesson. So thinking about, what do I need to see or hear from students that shows that they are meeting the skills and procedures. And then of course, in the next column is the resources required for that particular lesson. Okay, so when planning this unit and even looking at the new curriculum, From up until last year, a lot has changed since the former curriculum was developed in 1996. We had, how students learn through cognitive science and developmental psychology, which has really changed in the early 2000s, which has shaped and changed the way we look at learning and teaching. As well as I briefly in my science symposium talked about how we're developing scientific literacy, which was defined, those competencies were defined by PISA. But not only that, when we look at the research in the science of reading, when they talk about reading comprehension, there's real impact, and the research is really strongly showing that background knowledge has a big significant impact on reading comprehension of our students, and a real call for subjects like science and social studies that build background knowledge for our students. And also there is research in science education. The United States has been going through their own reform through the last 13 years. So a lot of research has come our way as well. So our science instruction and resources should reflect these changes. So thinking about what science is a way of thinking much more than it is a body of knowledge. So that's exactly what I'm looking at when developing this curriculum. Not curriculum, sorry, resource. I didn't develop the curriculum. So what we want to think about is these are the key ideas I'd like you to take away, and that's about planning for the new curriculum. So you want to use the learning outcomes first and the cusps to identify and pull out the key science ideas or concepts. And then you want to think about your students' context, like what are they familiar with that an investigation could connect to. And something, if you've been in the science symposium with me, I talk a lot about in the research that came out is using explore before explain in lesson development. And I'll talk more about that, as well as strategically the explain phase is when they use vocabulary, when to introduce it to help students make meaning and connect to those science ideas. And then we should, I think about or consider triangulation of evidence when we're doing formative assessment on how my students are progressing with their learning and meeting the skills and procedures towards learning towards the learning outcome. All right. So if we're thinking about bringing our science instruction to the 21st century, we're going to be shifting a few of our thoughts today. In our old curriculum and the resources that were developed at that particular time, a lot of them were activity-based. So what you typically got or received was a booklet that had maybe a student learner expectation with a series of hands-on investigations that were sort of disconnected to or from the perspective of the student and their development of understanding. So when we planned, we thought about our topic like solids and liquids and okay, what activities I'm going to do to support this? And it was about coverage. So when we're looking at this curriculum, we're looking at what are the concepts or what are the big ideas that I want my students to walk away understanding, and looking at something that students are familiar with, that they can build on their knowledge from each lesson. So it's from a perspective of coherence, that there's a beginning, middle, and end, which I'll kind of talk about. So the framework that I used for this resource comes from ambitious science teaching. And that's looking at having, if we're doing minds on or hands-on, that their minds are on and engaged. So intellectual engagement, as well as consideration that we have a high percentage of ELL learners and all types of learners in our classroom. So that attention to equity. And that's where I talk about explore before explain, and I'll kind of continue to refer back to that. So the framework has a process, and that is planning for engagement with those important science ideas, then getting from our students what they know. I was asked about yesterday about a KWL, and I don't know, in primary, I think asking, what do you know about materials? It's not going to be limited, and their knowledge is going to be limited, but there's ways of getting at it in a different manner and a different approach. And then looking at the lesson development as supporting ongoing changes in thinking. And then the students are going to give back to you their understanding through their explanations. Now it says pressing for evidence in primary from K to 3, we look, well, grade 1 to 3 really, we look at data. So support from data is the consideration. So when you think of science instruction traditionally, so there's either we did all activity based, or sometimes what teachers will do, and well intentioned, is and I did this at the beginning of my career as well, is, you would show a video, well, I've got to introduce this to my students, what this means, or I would have them read about it, and then they would go off and do the investigations. But what's coming out of the research in science education is that it hits some students. And this again has to do with attention to all learners in our classroom and their backgrounds. So if you want to think of doing explore first, students come with an understanding of how the world works. They may lack the formal academic language, but they definitely have some ideas. Like if I throw a ball up, it's going to come back down, but they may not know the term gravity. So it's thinking about when we attach that and do that so that all learners can kind of come and develop their ideas together. So what's the difference between topic-driven science and phenomena-based science instruction? And you're going to see some connections with project-based learning, but there is some difference if you've done that in your own classroom. So for example, we might do something like an activity like erosion. Okay, we're going to talk about erosion today. Disconnected from something that students have done before, or what do you know about erosion, or this is what happens when erosion happens, to instead giving context. So for example, in our curriculum, there's a lot of Alberta places. So look at Drumheller. What caused the hoodoos near Drumheller to form this way? Or, we have sky science previously in night and day. This is again being familiar with the students and their lives. We take the bus to school the same time every day. Why is it dark at 7:15 a.m. in December and light at 7:15 in May? They may have some inkling, but they may not, have the formal terminology. Okay. So if you want to think of this as you are building a sort of storyline, as what they used in the United States, what they refer to as a beginning, middle, and end, that your students are on a learning journey to make meaning with these science ideas. They start off with an observable event that they're going to be asked a question about. It's like a big question. That's where there's similarity between project-based learning. However, what they find the answer to is through small-scale investigations. And then when they start building some traction with the hands-on, and then they bring in some text, because the research has indicated that students who do both hands-on investigation and text significantly outperform those students who just did activity-based hands-on only or text only. And so they lead towards the end in which they will answer the question. So one of the criticisms in the research for project-based learning and things like this is the tax on students' cognitive load. So one of the things that you'll see, and it's been modified slightly for grade 2, is a learning summary table where they have the opportunity to consolidate their learning and synthesize things that they've learned. So for example, when they do a small investigation, you have the activity, what did we observe? What did we learn from that? And how does it help us answer the driving question? Okay. So these are examples of what a learning summary table may look like. The picture is the one from my classroom, and I have done this with grade 2 students in a classroom as well when I worked with a teacher. If you don't have the space to put this up, you can use a Google slide as long as you keep pulling the same slide up and documenting that as the students are working through the lesson. But how I've modified and adapted it for grade 2 was I did something called claim support reasoning, which you will see me refer to and bring up continuously through the lessons. Okay, so you might be thinking, oh, this is great. How do I fit this all in? I hear you. I've thought that myself. So that's where I'm a strong believer in integration. And if you look at the science practices, you can connect these to English language arts, language literacy now. For example, science terms and vocabulary. Well, there's a vocabulary organizing idea that explicitly talks about tier 2 and tier 3, which is academic words. Think, pair, share, and whole class discussion. You're going to see for students to be processing, are their minds on, are they engaged? So there's a lot of oral language happening. And that shows, this is from Hattie's research or meta-analysis, that there's a significant impact over a year's worth of growth when your students are talking and discussing with their ideas. And of course, at certain strategic moments, there will be viewing and reading various texts, video and nonfiction. So comprehension and text forms and structures fit in. So what I'm saying to you is, yes, you need your dedicated 400 minutes. You need some of that to be dedicated to phonemic awareness and phonics and developing that. But think about taking the 15 minutes that apply and the skills and procedures that apply and add it to your science lesson, so you're not limited to a 30-minute time frame, so that your lessons can be more robust by including that, because language arts is really about communicating and understanding ideas. You know, you view and represent ideas, you read and you write about ideas, you talk and you listen about ideas. Okay. I talked about the framework. Sorry. Okay. Don't know how that happened. Okay. So in the United States, as I was mentioning, they call it materials or resources or materials, but are a huge equalizer in the classroom, especially for students with special needs and English learners. Students are figuring things out and actually doing science rather than just being told about science. So now I'm going to walk through the planning process of the resource that you're going to receive today. I'm going to start with the learning outcomes and then unpack the cusps. And then I'm going to look at the science ideas behind it. Okay, so when we I looked at the matter learning outcome. Students investigate properties of materials and relate them to purpose. Right away, you're seeing the word investigate. That's what they're doing. That's a straight connection to the scientific methods. And materials and relate to purpose. So how does this material, what is the reason for using it? How does it help this object? What is the best material for it? And we'll look at those ideas. In the scientific methods, the learning outcome is students examine investigation, because in grade 1, they lay the foundation. I realize this is a bridge year this year, and explain how it is influenced by purpose. So you can see that purpose is quite important in grade 2. So then I looked at the cusps, and I always start with the understanding statement, because those are the pinnacle of where you're working towards with the learning outcome. So materials have unique properties. That I know, because that's how we get the purpose for them. I zeroed in on that the students would probably investigate that water is absorbed and if the material can be shaped. Now, when I looked at the other two, now it says include, so that means we do have to teach all of them, or the students need to learn all of them. But I saw a good connection with the other two, with energy organizing idea of light. Having taught grade 4 before, I know that light travels in a straight path and interacts with different materials differently. So I felt that I'm going to leave that for then. And I would say you can pull apart. The cusps are put together as a guide, but they're not something that's dictated to you. They actually want you to feel free to adjust them. So that's kind of what I've done here. And then I looked at the skills and procedures, testing properties of various materials. The properties are outlined in your knowledge statement, and I'm picking up on the water's absorbed, that material can be shaped. And they're going to have to measure using non-standard units. When I see measuring, I always go to the math organizing idea, because I want to streamline my outcomes, right? And really integrate as best as possible. Then I look at purpose of an object is influenced by the choice of materials used to produce it. And that some materials the students are thinking about are more suitable than others. So then I looked at compare the properties, and I'm like, okay, this is testing and the results are going to be comparing, and I'm going to look at the science methods for this. Explain the relationship of the suitability. I looked at this cusp as well about materials can be combined in a variety of ways to make objects. So I was starting to formulate in my mind about where I would be going with this, how the students can use this authentically, and that materials are used to make objects. So that's the ultimate goal and purpose of this. And then I looked at the knowledge statement about the occupations, such as means it's a sampling. So I focused on engineering and designing. But then I thought about, about creating and the skills and procedures behind that, combining materials to create an object. That to me kind of went with select a material to create an item for a specific purpose, and then discuss your choice for that. So it's kind of setting my mind up for how I might be organizing this. But then we need to think about the bigger ideas in science and connect it back, which I'll share with you. And it's pretty straightforward. So knowing that properties are characteristics or features of an object or material or matter that are observable, measurable, and they're used to describe these objects and materials, but also to understand it. And I'll talk about that briefly. So looking at where your students are coming from or will be coming from as they work through this curriculum, they're going to be looking at describing properties of a physical object. That can change, and that's where they're going to come in. So I've, bold printed our curriculum expectations that students would work on, but I'm going to contrast with grade 3 because that's where they're going to, and then grade 2 is kind of a bridge between both of these. So in properties of matter, it's actually looking at the substance itself, and it doesn't change. And the reason that they do this is so that they can identify these substances. So there's a purpose behind doing this. And in objects, it's to be able to describe it. And I listed below. But in grade 2, the properties of materials are both. They are about the substance itself because material, can change it, and they learn about that in grade 1, but the material stays the same. So there's a bit of both happening there. So my colleague Ted at ERLC put this together, and I kind of looked at it, and he pulled apart the concept. So we're looking at materials, and they're testing and comparing these materials for a reason, the properties of them, to be able to select a material for the best purpose of an object, so that particular object needs. Like you have a pencil, it's hard, it's not going to be soft because you can't write with it, sort of those kinds of things. So there's many different types of properties, but our curriculum focuses on can be shaped, it's see-through with a transparency and absorbency as well. Then I looked at the skills and procedures and from the scientific methods. And if you were in my session, I talk about the procedures that scientists use, and I created a graphic organizer, which you'll see today, because it's a cyclical process. It's not something that an iterative, you're going to see that your students are going to go through this when using this resource. So this is the procedures. And of course, we have the skills and procedures itself, and you'll see how your students will be working with those in the scientific methods. So I kind of aligned here some of the skills and procedures from the matter and where I would see it, like things were starting to formulate in my mind when I was developing this. So I always keep the end in mind. And I said I was thinking about creating materials for an object. So designing a bandage, basically, because again, the company is going to need them. They've been researching and working with materials. So they are becoming material engineers, which is a real occupation. And they're going to have to do tests on different materials to choose the best one. And then I designed a single point rubric in consultation with our assessment consultant, which you'll have access to as well. And I'll walk through that a little bit more. But as I'm planning for the lessons, I'm thinking about formative assessment. And so in the lesson, you're going to see, or the sample unit plan, you're going to see assessment look-fors. So when we are scientists of our students' learning, we're gathering evidence. And to be valid and reliable, we want to make sure we're triangulating it. So we're observing our students. And I think in primary, we do a great job of that. So just ensuring that we are gathering the evidence through our anecdotal records, checklists. Our students are having conversations and talking to each other, or we're talking to them to get what their understanding is. So what do we want to see or hear from students? And obviously at the end, the performance task is a summative product that they will be doing. So there's a bit of triangulation of evidence happening. So the question I'm thinking about is, what do I want to see or hear from students that shows me they've met the skill and procedure? So what you're going to get linked to, and you can use, it's a forced copy, is so that you can modify it or use it, is I've created a formative assessment checklist that you may or may not want to use. And I'll show you as an example where I would use it in a lesson and how I'd use it over time. Okay, so, and of course that's met, approaching, not yet, which is kind of your formative assessment check. And as I'm developing lessons, I'm thinking of instructional strategies to help my students make meaning. There's a lot more. I'm just going to highlight that students can draw and write to make meaning. Think, pair, share, because if you pose a question and you get no response, it's a great way to engage all learners. I use thinking routines, which I'll talk about, and then I include vocabulary development at strategic times. So I start developing the lesson. I think about how am I getting students to think with and about the science ideas they're learning so that it builds on what they're learning from lesson to lesson in a coherent form for them. When students are using hands-on activities, are their minds engaged as well? And that's where the science methods will come in. And how am I engaging all learners? Because learning is a consequence of thinking from cognitive psychology. So if our students are thinking, they're learning. So these are things you can go back to after with variations on think, pair, share if you've done that in your classroom. Strategically using gradual release of responsibility. I don't use this linearly. Sometimes I do model or I think, like a think aloud. I might do it more guided interactive where I want them engaged. So we think together. And then eventually our students are going to be able to do it by themselves and then with partners and then by themselves. For vocabulary, the importance of having a science word wall when possible, because we have a high percentage of ELL learners, or even just the vocabulary in and of itself is challenging for students. As a elementary science consultant, I know for grade 6 PATs, that was one of the most sort of limiting factors in reaching science. And that comes out in the research as well, and why we want to do explore before explain. Because that can interfere with students' ability to show what they know and build their understanding if we start with it right away. And how are we introducing vocabulary? So, using a Freire model, and I'll kind of give an example of how I've done that. And then this is an example in a kindergarten classroom where you get the students to help work through that, but I'll work through that in the lessons. But if you're going to have like a glossary, just ensuring the word cloud is probably easy enough, but if you look at the definition, a collection of water vapor that can make precipitation. A lot of those words, even for grade 5, would be very difficult. We have to ensure that students are making meaning of the vocabulary and understand it. Okay, so we're going to walk through the lessons now and how they kind of unfold. So the investigation they're going to start with is about why are bouncy balls so bouncy? So the first lesson is going to help students ask questions, right? But in science, when scientists are asking questions, I know I have it, it's not always starting with a question. They actually notice something and observe it. So we have to provide that context for our students. And by doing this, we're going to access prior knowledge and find out what they already know. So for example, because we all look like that in September. But you would say something like, I was walking around during supervision and noticed children were playing with balls. Like, this is something familiar to all students. I wondered, what makes a ball so bouncy? Why do some balls bounce more than others? So this is the observable phenomena. It's nothing, it's just an event, it's just a situation. And then I would present, these are a list of the balls that they're going to be investigating. And most of these you can get in probably your gymnasium, and some of the other ones like tennis or ping pong or a golf ball can be bought through a dollar store. So you provide them groups or partners, however you decide, and you just get them to kind of bounce them and look at them and observe them, and then pull them back together, whole class. And it's not just what do you notice. Sometimes that becomes problematic for students because they don't notice the details. So, kind of let's talk about the color, the shape, the texture, the bounciness. Is it bouncy, not bouncy? And then introducing the name of the type of ball it is, right? Because not all students are going to know that. They're going to have played with a ball of some kind. So there's that familiarity. Now, our students in grade 2 have to develop questions for the purpose of an investigation. This is going to be a year-long process. I used to do this with grade 4s because I had them plan, and your students are planning an investigation. So I would have them at the end of this, like, what's their ideas? So as they're drawing, as they're writing, I would have them go and I would walk around and kind of ask probing questions. After they've done that, then I would ask them to come up with questions. They can write them on a sticky or however, and you should gather these questions and kind of look them over at the end of the lesson before the next lesson and put them into sort of similar groupings, okay? Because in the next lesson, now we're going to get them to be part of the planning of the investigation process, because students should be involved in that. How do you do that in grade 2? There's a guided process. So because they're doing that, what you're going to do is kind of a guided question sort. And you're going to have on the board questions we can investigate and things that we're not able to investigate. And this is going to be more guided approach from you. So it's going to be kind of like, there's things that we can realistically do in the classroom and things that we're not able to do realistically for time, for money, for, things like that. So start kind of sorting with them and presenting it to them and asking them and guiding them a bit. So for example, what is the bounciest ball in the world? Could we really find that out in our classroom? No, we couldn't. It's a great question. I wonder that, but I don't think we can investigate it. Why are some balls more bouncy than others? I'm just putting that as an example, right? And if you go back, this one that I said, why does a bouncy ball bounce but not a baseball? That's a great question, actually, and it probably would come from a student. That kind of is under the same more generic why some balls are bounced. That's why I said grouping them and guiding students to say, this is kind of a similar question, but let's look at all balls that some are bouncy, some aren't, and let's try and find that out. Okay. So then students are developing questions for the purpose of an investigation. So in the student graphic organizer, what are we trying to find out? Because just because we do a hands-on investigation doesn't mean students know what's going on. Some of them don't. So it's like, let's work through this. Let's talk to your partner and then write it down together. Out of all the balls, which one is the bounciest? Let's turn that into a question. Then, as the students are planning about the observation phase, you could pose questions such as, what could we do to observe to find out the bounciness of each ball? What could we count or measure? Because what you count and measure is what you're observing, right? To find out how bouncy they are. And so they can do a think, pair, share. You might get a little out there questions, but eventually it's going to come to, I think we could countermeasure the bounciness of a ball by. I do sometimes put pictures up, especially in primary, and you can do some prompting questions as you circulate to listen to them. Do you think some balls will bounce more than others? How could we count or measure that? Okay, so it's getting them to think, getting them to process. Now, in the knowledge statement, in the scientific methods, it talks about how the repetition of an investigation includes performing the same procedures in the same way. And observations and data should be similar if the investigation is repeated. Fair test. That's where that kind of comes in. So a good discussion to have with them is, when scientists do an investigation, other scientists go off and they do the same one, and they look to get the same results. And so you can prompt some of their thinking, like, we need to get the same results. So if you're observing or counting the number of times a ball bounces, should all groups have the same number or should it be wildly different? Well, we should have the same. Okay, but what happens if some groups, so these are some questions for them to think about, bounce the ball on the carpet and the others bounced it on the floor, but they get the same results? No. Would it be fair if we dropped one ball from shoulder height and then one on the ground or on the stairs? No, that wouldn't be fair. It has to be the same. They have a sense of fairness, right? What if one group pushed the ball really hard and the others let it fall gently. So you're starting to get parameters for the planning of the investigation. So then they could consider a fair test. So what's the one thing that changes? The type of ball. What are we measuring, observing, counting the number of times the ball bounces? What stays the same? How we drop the ball, the height at which we drop the ball, and the location, right? This floor. So then again, the think, pair, share, they can kind of help you answer those kinds of questions. Then they're ready to make a prediction. Because although in our curriculum, it says a prediction is a likely answer based on their current understanding. Absolutely, we want to get that reasoning. But it's also really an anticipation of an observation. So because they've been so involved with you in developing planning the investigation, they're thinking about it. So they can do this verbally, or they can write it down however you want. I predict the ball, and they can say the type of ball. Now that they know the different types, you've created the chart, it's up. They might say like the bouncy ball, the tennis ball will bounce the most because, and then they should kind of give their current understanding. Okay, so now they're ready to perform it. They've planned it, they've been a part of the planning. Now they're ready to observe and record the data and do some analysis. So you might do a quick recap, and I just want to show you how you can model. You don't have to show this video, it's very boring, but this is just how you can model for them how to drop the ball. There's no sound really. Okay, so she's going to drop a dodgeball. You can see with her hands, she's just gently letting it go, and she does the same thing over and over. Okay, so it's getting them to practice that before they go off and do the investigation. And then you can consider putting them in groups of 3, and you can consider assigning roles if you'd like. One person's the ball dropper, recorder, or counter, however works for you. And then in the investigation sheet, they can count or do a tally of the bounce counts. Okay, so here I brought in the statistics organizing idea from math, where they record data on a table and construct graphs to represent data. Now, at this time of year, if you're doing it in October, then there's more guided in practice involved, or more guidance from you. And the students are comparing their observations and data with others in the skill set. Okay, so once that's been done, the next lesson is getting them to analyze the data. So you can start with having them look it over. Which ball had the most bounce, which the least, pretty easy to get from a graph, which is why we graph. Why do you think some balls bounce higher than others? Not so easy from a graph, and that requires a little bit. Now you can compile the data, which you're supposed to, where they're supposed to collaborate and combine it. So then everything's kind of on one and they're dealing with the same data. What they can do now to do an analysis is to go back at the same balls that they're investigating and sort them from the high bouncers from the graph to the low bouncers. And they can do a Venn diagram. And then it's like, I think blank causes some balls to bounce higher than others. So they're starting to get to the materials. They're starting to think a little bit more. They may have a little bit more of an understanding, but they're really investigating that. Okay, and then you can record that as well. So here is that consolidation of learning and synthesizing. So they're gathering data to make a conclusion. So they don't fill out the top part, which is the answer. The claim is an answer to a question, or the bottom. They're just collecting the data together. So the graph show that the balls that bounce they seem to be having rubber, or the material seems to be the same. Like they could be describing it at that point. They may not necessarily say rubber at that particular point. Now, this one is an interesting one, and so I really thought about it from your perspective. In this particular lesson, they observe the inside of a ball to determine its materials. Okay, so I think cutting up all the balls is just not realistic, although you may want to go that route, that's fine, and have a set for yourself that you'll use. So I created some options, and I probably would do the first option realistically myself. So you can, tennis balls, I have broken them apart, sponge balls and ping pong balls can be done. If you need help or assistance, there is a saw at Home Depot, but basically you want to give some hands-on so that it's tangible for the students. But this video, actually the water jet cuts up all the balls. And so I've listed the seconds here that you can share with the students, but they'll just see what's inside the ball, and it kind of talks about it. And
what do we got?
Okay, I'm not going to show that. You can watch that later. Then I would introduce the term material. Okay, what material, what are things made of? Because if they're going to go off and observe the ball, they need to, like, we're looking for the materials. So what is a material? It's what an object is made of. If you have a science word wall, we can kind of put that up. So here the students have been observing and recording their observations. And if you were with me in the summer symposium, I would provide a list of words of the materials so that the students would have it. The question from Taylor is that would we have to buy a saw, or would they cut it for us? I believe they do cut, but you'd have to double check on that. There is a link about a PVC cutter as well, but that's why I would probably use the smaller balls. It's a little bit easier. But you can see here the baseball, he's labeled it, because I was sitting there going, which ball is which? So it's really important because this is a form of communication. And, you know, when they're labeling the different materials that the balls are made of. So then these are questions for discussion after that they've, like, what are the different balls made of? What patterns do you notice? So you're going to hear that sometimes, because patterns are what we look at for analysis in data, because what repeats is an indication of something. So all the balls actually have some form of rubber inside them when you compare them. What materials are in balls that bounce really high versus low? Why are different balls made? Now you're getting to that point. Why are different balls made with different materials? What material is bouncy ball made of, and how would you describe it? Okay, so they can have that discussion and do a little bit. Now that they've observed inside, we're collecting data, and then they can write that down and work through that together with you. Now is when I would do some formal introduction. They've been doing a lot of investigating, and now I would have them look at and read about or watch a video. This happens to be reading. So we would talk about properties of materials, because they're going to be listening to a book about materials. So this is where, you know, this is complicated. So I would help break that down with using a Freyer model. And I said I was going to talk about that. So Freyer model is a definition, or you can talk about it and say, okay, now turn to your partner. What does that mean? Tell me in your own words, and then kind of get a student-friendly definition with them. Talk about the characteristics of the different properties. You can see through it. It can soak up water. It's an introduce absorbent, or you can wait later. But really getting the students to come up with examples and non-examples of properties of materials, and list on that as well. So that when you put this up, it means something to them. They have processed this. They've been thinking about it, and it will stick more that way. So these books are recommended. The Material World has a series of different materials, and it is sold on Amazon.ca. It's very popular. Some people sell it used, and it's about 26 bucks, but Amazon.com also sells it. And this one from Acorn Books also has a series on different materials, and it's more at student level of reading. So then what'll happen is the read aloud will be done with them. They're thinking, like, they know what a material's properties are. So this may take a couple of days, depending on your context. And then you're going to ask them, and they may work with a partner to do a concept map of the different properties of rubber that they heard. Okay, so that through that discussion. So you can see the example here. And then, the students wrote about it. You can have them write as well. You can have them talk a little bit and then write about it. What are the properties of rubber? How do the properties of rubber make it useful for different things? Because it goes and expands on that. Which property of rubber is most important for making a ball bounce? Where does rubber come from? Because although there's a couple of cusps. There's one cusp through 2 or 3, or things that I haven't covered that you're going to have to work through after. And one of them is the natural materials and processed materials. But this is a good start, because it actually in the book shows that rubber comes from nature, but it's also can be made by humans. All right. So now they're going to look at the property of, and ours can change shape, or it can be bent, or can be shaped. So this particular investigation, small scale, is testing the stretchiness of various materials to see, which would be the best for their balls, or different types of balls. And so they're given, this is a list here. The leather, they said ShamWow, but I think that you could kind of modify that. Now, going into the math organizing idea, I looked at, it says non-standard iteration. So I was looking at tiling. So they look at the material before stretching and the material after to compare. So what you might see is something like this. Of course, this is an American length before, length after. This is a grade 2 classroom, by the way. So I've kind of put on here that instead of using a ruler, they would be with partners and use tiles to measure it, and then measure after. So this is where I'm going to kind of demonstrate for you, because at each lesson you're circulating and observing and recording for formative assessment. You're assessing the skills and procedures, right? And the task or the investigation just allows the students to do that. So you can zero in on 5 students at a time on every lesson for different skills and procedures. So met, approaching, not yet. So you can see I didn't really comment on any of the students. Where it says not taught, it's just how we haven't got there. It just flags for me, oh, I need to assess these students the next lesson. But anyways, Elon Musk. Elon struggled to line the tiles next to each other for the stretching the rubber bands. He was not able to use the measurable properties to compare the different materials. He compared his data with others, but he required prompting and guidance to check how to make his results the same as his group. So just some things that you can note and think about if students are struggling as you work through that, or if you choose to use this. So then they should reach a conclusion of whether it's stretchy or not stretchy. They don't need a placemat. You can just use stickies that they label. So then they take the data and sort it after to analyze it. So they've been working with materials and stretching rubber bands, but it's hard to see a bouncy ball change shape. So this is a slow motion video. I'm not going to play the whole thing, but you can see, and the students will be able to observe through the video how the ball, through slow motion, changes shape and how the rubber helps that. Okay, so students are they've collected a lot of data, so they're going to make a conclusion. And you can see here they get 3 pieces of evidence. They draw pictures. They can, use a journal. You don't have to use my graphic organizer, as this particular teacher has used a journal, whatever your comfort level is with. But have, again, prompting questions that they're going to draw a model, as they did here. That's what a model is in science, to describe the shape of the ball as it changes, that they've observed. So they're processing it. What property causes the ball to bounce? What data do we have to support that claim? So at this point, or up until this point, I don't know your classroom, but not all students are familiar with different sports with the different balls. So then I have the slides available at the end that have all of the different sports that connect to each of those different balls that they've been investigating, because now this might not be familiar for all students. So we want to level the playing field in our classroom and kind of show them that, or if you want to show videos as well. But now they're able to make a claim. They can look at all their data. What is it indicating? Because that's what happens in real science, that the bouncy balls are bouncy because of the rubber material. But the reasoning pushes them to support that a little bit. They should be using some of the new science vocabulary, like properties. Properties of rubber make it useful. The rubber helps the rubber ball bounce because it has the property of stretching. The rubber can stretch and return back to the shape after, which gives the ball bounce. That's just an example, but something to that effect. We want them to use the vocabulary in a sentence at this particular point. So these are examples now that you can see of how the students have done that investigation in grade 2, where what they wrote as exemplars as well. So look at the beginning. Okay, she said rubber. or he, I don't know who wrote that, but you can see more of the vocabulary development, more understanding in at the final response after about 4 or 5 lessons. So that's what the research shows, that students writing and drawing over time becomes more sophisticated as they work through some of these ideas and they're allowed to develop these ideas in the classroom. So we can expect that students are going to be offering the right answer right away. They need multiple times to talk and write their way towards fluency and scientific accuracy, and they will get there and they will really shine. And that's something you can refer back to, is about, detextualizing science vocabulary so that, they're not given something to memorize. I don't think you would do that in primary, but, or, introduce it first, just doing it at the right time. However, I talked about creating the bandages. So those of you who are doing sessions with Chris and Ted, they talk a lot about surface deep transfer. So you can see I was taking the students from a surface of just a rubber ball. Then they started deepening their learning and making connections about the material, like the property of the rubber ball, the material, bringing that together. Now that they've learned about that particular material and its properties, I want to give them an opportunity to apply it in a new context. And that's where the performance task comes in. That's where transfer of learning really happens, is in the assessment phase. Okay, so this is where students are going to be doing, so before I get them to do that, I'm going to give them other objects to sort and just see where they're at. Do they think about material? I'm not even going to talk about materials. I'm just going to ask them, present them with a number of different objects and ask them to sort them. Then this book is on Epic, so you can get that for free, or if you choose to order it on Amazon. It's really good. It's sorted out, and then they can go back and relabel their sort. However, this is where physical properties of materials, and it expands on what we've introduced, the term physical properties. So they're going to have some background knowledge built up that they can connect to and expand on from the next lesson. However, when I show videos, again, I'm always thinking, how are my students engaged? How are they thinking? This is where the thinking routine comes in, connect, extend, challenge. And I've used this in grade 1, I've used this in grade 2 and 3, and all the way up to grade 6. So how I do it with younger kids who haven't done it before is I say, okay, we've been working a lot with property of materials. I'm going to show you a video, but tell me first, what do you know already? That's the connect column. And so you give it a list from them. They can do a think, pair, share, whatever, however you do that. And then when I play the video, I pause it strategically because they need a bit of guidance in primary. And I'll say, okay, is this information we already know, or is this new information? If it's new information, it goes under the extend column. And I may use a different color just to distinguish it and write it down. And then if it was something they already knew, I'd put a check mark beside it. After the video, and they should be asking questions. And what questions do is it not only piques curiosity, but it gives you insight as a teacher. Students ask questions about things they don't know. So I've done this with grade 6, and I've been like, I remember it was about air being matter, and they asked me, I don't understand how air is matter, and I was like, we went through this, So it was really good. It gives you insight into things that they're wrestling with. So they can write it on stickies, or they can tell you. Teachers have written it down and put their names beside it. They like seeing their names. Okay, so now they're going to think about the actual performance task. I wanted to expose them to different ideas. So in the handout, there's the one for the designing a bandage. This is where I connected the knowledge statement about properties of materials and the purposes are important to many occupations. And then I picked engineer or materials engineer because that is an actual occupation. So it is a little bit about it. You can read it to them, read it with them, however you choose. But then they need to think about what makes a good bandage. What do you need from a bandage? And I'm thinking a lot of them are familiar with it. And I would, and then, how do we use them? What properties of materials do you think that are needed to make a bandage? And this is the single point rubric I was mentioning, so that you know this is the skills and procedures test properties of various materials. They test and compare the properties to find out if it can hold water, compare the properties of materials that can be shaped. They were doing that, but in a different way now. And then select material to use it to create an item for a specific purpose. So tell me what you found when you were testing out, and how does it help you decide what material you chose? They combine the materials to create the object. So they choose and combine the appropriate materials, yes, but the bandage is functional. It has to work because it has a purpose or a function, right? To a point at a grade 2 level, let's just say that way. So if it has to attach, they're combining the materials to attach it, that kind of thing. And then of course we have to summatively assess something from the science method. So what I've chose here is describes procedures of this investigation, and I'll share with you how I would do that. So this is a teacher decision because you've led the class through a guided planning of an investigation already. However, I'm not going to assume that all kids, like I would maybe still do a guided practice. That's your call. Does the whole class need more guided practice with developing the questions for the purpose of investigation? Are students ready to complete this with a partner? That would be your classroom, your students, your context, your decision. Okay, so then discuss with students, and then you could document this or put this on an anchor chart. What does a good bandage need to work well? What makes a good bandage? Based on what a bandage needs to do, right? Like it needs to, cover a cut, protect it. Sometimes we bleed, so it needs to kind of absorb liquid or the whatever, what's the best material? So some potential answers could be protect, soak up liquid, stay on your body, move and be flexible with you. That's where the can be shaped comes in. Then now they have a purpose to do the actual investigations. Instead of just giving them an investigate, here we're going to test materials, who cares? But this is the purpose, because they're going to have to use the results of their investigation to design a bandage. So they're going to spend, I think, about a day. So you're, again, a decision of yours. Some teachers like to do stations. That can be really challenging because you have to really make sure students know what to do at each station. Personally, if it was me, I would just spend a day and do it and model at the beginning and then kind of go and observe and listen to the students, but it is your call. Okay, so in the graphic organizer, it looks something like this. Same materials, actually. There's an addition of a few, because if they talk about protecting, the plastic bag goes in. These are the same materials from the rubber ball, but there's a few more listed. So you can get pipettes on Amazon. They're pretty cheap for like 200. You can get for $16. And they can complete as a group or in partners and through discussion. So, how, like you would model how to make a droplet, how to pull up the water. And then did it soak up water? Yes, no, how many drops? And then they make a conclusion. It was absorbent or non-absorbent. Okay, and work with that. Can it be shaped? Can you bend it? Can you twist it? And if you have a 1-2 class, this is probably a connection to grade 1. But again, the materials does it bend? Yes, no, yes, no. Check mark, can it be shaped or it's not able to be shaped? Okay, I'm looking at cardboard, that's probably 1. And finally, they're probably going to talk about it being strong. So they can do a strength test. This is not part of our curriculum. And I talked with our assessment consultant about this, and we just said, just don't assess it. They can do this, but they don't have to assess it. So basically, it's like they create a little bridge with the material between the textbooks, as you can see, and they use washers to test the strength of the material. And then they say if it's strong or weak as they're making conclusions. So now they're going to use the data in order to choose the material that they're going to make their object or their bandage from. So that can be co-constructed with your students. So you can prompt with questions such as, when planning to design your bandage, what should you use to help you choose the materials? Okay, and you can guide them about looking at their data. Well, the ones that soaked up liquid the best, that can be shaped or strong. So you have to look at all 3. So it's a little bit of comparison. So you may choose to do a chart together as and compile it as a class as well. That might be easier. When planning and thinking about choosing materials to put the bandage together, what should you think of including for the materials? So you might get, well, you have to attach it to the body, it has to stay, or it has to protect the person from getting wet. Lots of different things, right? So they might put a plastic bag over top their bandage that they design. So again, they have this form that they've worked through with the rubber ball, the bouncy balls. You again can make that decision of like the support from data comes from the investigations that they've been working on. And then the material that makes the best bandage is this. The material, I don't know, gauze is when tested had the properties. So they should be telling you what properties it had, making it the best material to make a bandage. Then they plan out and design their bandage. And I know design thinking has been kind of around. It's not part of our curriculum, but I've kind of connected what we were doing to where it is on this design thinking, this particular process. The criteria of a good bandage is, empathizing or defining it. And then when they ideate to plan, they have to base it on the results. They're not just going to grab any material, right? They have to think about what they know about the material they tested in order to choose it. Then they design the bandage, but again, does it work? And you can continue to go, if they need to go back, oh, this material didn't work out, but, kind of thinking about it that way. So these are examples that students will test it. I wouldn't attach it to a real student. I would attach it to a stuffy or a doll as an example. So for today, I hope that walking through this example that you will have an opportunity to use in your classroom, you know that looking at the learning outcomes is really important to start with, and then looking at the cusps to pull out some of those key concepts or key science ideas as I've discussed today. And then thinking about providing an authentic context for students to investigate so that engages all learners at some level. And explore before explain in the lesson development. So I hope you saw that today, that it allows all children to get in and be part of that process without being blocked by the language. Using talk and vocabulary strategically as they're making meaning in science is very, very important, as well as triangulation of evidence with student learning. Okay, so before we talk about that, there are the additional resources on these slides, which are the books. So Material World has all of these other materials, as well as the Acorn series. And then these are the slides that you can use with your classroom to sort of, for different students who may have different backgrounds, but also draw on the students in your classroom. Like I forgot about marbles and jacks. I haven't done that in a long time. Okay, so if there's any burning questions, now would be the time to ask them. But I do want to thank you for joining the little session live today. For those of you who have taken the time today, and I saw some of you were driving, and I was like, oh, okay, I'd like you to choose a number. I'm going to give away a set of books that connect to this lesson. So I'd like you to choose a number between 1 to 100, and under that little square or the block there is a number. And the closest number or the person who gets it wins. So I'm going to give you guys about a minute to load up all your, get in here and get everybody. Yes, the link is going to be shared today. I'm going to do that right away as people are putting in the numbers. I'm going to share a link to the resource itself. And in the link, there is a link to the slides today as well. Okay. Okay, I'm going over. Okay, gonna give you a couple of seconds to get your numbers in. Okay, I don't have anybody else putting in numbers. Okay, I'm gonna select and show on the slide in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I think somebody got a closer number. It was a really low number I gave you guys. I gave you guys 3. I think the closest number I saw in the chat was 8. So I'm just gonna look back here and see if Sheila. So Sheila, can you drop in the chat your email address so that I can contact you and send you, congratulations, Sheila. I can send you the books. Okay, now's the time to open up your mics and ask me any questions or anything that you'd like to know. And thank you so much for coming today. And congratulations, Sheila. And please give me your email. Thank you. Oh, thank you, Sheila. I'm just going to hang here for any questions. Sophie, great question. I let our French consultant know. So she's going to be, she knows about these resources, so she will be translating them. I can't tell you when, but they will be posted on the site. So anybody who's still here, I'm going to show you the site. That's www.arpdc.ca. Believe, oops, okay, then let me just Google that and show you. I might have, okay. So if you go to ARPDC site, there's a lot of new curriculum resources here, and here is the science one. There's also professional development that is on here as well that you can access. So these will be posted on the ARPDC site, and you can see emergency in this here. So I will be giving them to her as well. But feel free to open up your mic, ask any questions or anything. I'm going to stop recording. Oh, Sophie, your hand is raised, or did I answer your question?
No, you for sure answered my question.